Today on Engineering Newswire, we're checking out the first ever World Drone Prix, developing Boeing's latest unmanned undersea vehicle and building Microrobot tools with Microrobots. Boeing has designed both manned and unmanned deep-sea systems since the 1960s, but their latest vehicle just might be its most forward-thinking. Boeing recently introduced its latest incarnation of an unmanned undersea vehicle, or UUV, called the Echo Voyager. The most obvious characteristic that distinguishes this UUV from other Boeing models is the Echo Voyager's enormous size. Measuring in at a whopping 51 feet in length, this UUV far surpasses the 32-foot-long Echo Seeker and the 18-foot-long Echo Ranger. But what really makes the Echo Voyager the star in Boeing's family of UUVs is its ability to operate autonomously for months at a time thanks to a hybrid rechargeable power system and modular payload bay. This means while at sea, the UUV will be able to collect data, rise to the surface, and provide information to its operators in a near real-time environment, all without the added expense of a surface ship or a crew. The president of Boeing Phantom Works, Daryl Davis, even called the Echo Voyager a new approach to how unmanned undersea vehicles will operate and be used in the future. Boeing will begin the Echo Voyager sea trials off the California coast starting this summer.
A few years ago, the research institute, SRI International, introduced their Microfactory platform, which uses hundreds of tiny robots that work together to build macro-scale structures. These minuscule robots, we're talking smaller than a dime, can build structures that even contain integrated electronics. The microrobots are essentially just small magnets with all the intelligence built into the substrate they travel on. Printed circuit boards drive them along electromagnetically, but their end effectors have to be altered depending upon what you want the microrobots to do. But because building a bunch of small custom bots is rather tedious, the Research Institute now has microrobots making custom end effectors for other microrobots on demand. The robot manufacturing tool uses a probe to pick up a droplet of curable liquid and then sticks it onto the corner of a waiting microrobot, where it hardens. Then the worker robot rinses off the probe to prevent unwanted buildup of the curable liquid. The process is repeated over and over until you've got the tool you need, whether it's a hook or a fork. So instead of having to buy a bunch of special purpose robots to complete tasks that may change, you can just buy standardized robots and outfit them with special purpose tools that you can fabricate yourself on site. Someday, this could mean micro-robots living inside larger robots, monitoring and repairing them. Creepy cool.
Last weekend, the first ever World Drone Prix took place in Dubai, with the $250,000 prize going to a 15-year-old Brit named Luke Bannister. The Drone Prix tested the participating pilot's skills in operating high-speed quadcopters while navigating a neon-lit obstacle course with hoops and whatnot, strategically placed around the track. Even more difficult, the pilots had to navigate the track all while wearing goggles that displayed a live feed video from the camera strapped to the piloted drone. The race consisted of 12 laps across the windy 600-meter track that forced racers to make snap decisions about optional shortcuts. The occasional pit stop was also required, as the drones could only perform these dizzying feats for so long without a battery swap. 15-year-old Bannister was one of the around 30 drone racers who participated in this historic event.